All right, y'all. So 8.4 is titled Theorems About Zeros. All right, y'all. So the first thing they want us to do, they want us to find polynomials when we're given the zeros. So we're going to find a polynomial given its zeros. And remember, the zeros are just like the solutions to these polynomials, okay? So for my first example, they want me to find a polynomial of degree 3 that has the given zeros. All right, so for my first one, my zeros will be -1, 2, and -8. So they're giving me 3 real number zeros for this one. Now, when I'm done, remember my polynomial has to be a degree 3. And what they mean by that is that my highest exponent has to be a 3 when we're done. So I should get some kind of x to the third and then whatever's left. So the first thing you want to do, remember, these are all solutions to the polynomial when they're giving you the zeros. So I come in and I set each of these as an equation. X can equal -1, x can equal 2, and x can equal a -8. So my 3 zeros, remember, are my 3 solutions. So y'all, the first thing you want to do, so first thing we want to do is get a 0 on the right side of all these equations. So basically, if I want a 0 on the right side, I'm going to add its opposite of that number to both sides. So since I got a -1 here to make it a 0, I'm going to add 1 to both sides. By doing that, I get an x plus 1 equal to 0. Got a +2 on the next one, so I'll add a -2 to both sides. So that's going to give me a x minus 2 equals 0. And then my third one, I got a -8, so we would add a +8 to both sides. So now I get a x plus 8 equals 0. So now I got 3 equations equal to 0. So what I'm going to do next is set up each of these equations as a factor. So set up each equation as a factor. So what I'm going to do is put all these 3 equations, the left side, I'm going to put in parentheses. And my first factor will be the x plus 1. My second factor will be the x minus 2. My third factor will be the x plus 8. And all of these at the moment will be set equal to 0. So y'all, if this factor is equal to 0, this one's equal to 0, and that one's equal to 0, when I put them all 3 together and multiply them, they're still equal to 0. So what we do? We set up each factor as we set up each equation as a factor, and we've got it set equal to 0. The third thing we're going to do, we're just going to start foiling these until we get a final polynomial. So we're going to FOIL until done. Now remember, when I get done, my highest exponent has to be a 3, since they told me that up here. So I'm going to show you what I'm going to do. I'm going to FOIL these last two together, because I think it's easier. You'll notice when I FOIL two of these, I'm going to get 3 terms for the next polynomial. And it's often easier if you keep the 2 terms up front, and then I'll show you when we get to that, okay? So first, I'm going to bring down the x plus 1. Now, I'm going to FOIL the last two together and put that in my parentheses. So to FOIL this, we got an x times x is an x squared. X times that 8 gives me an 8x. Now we distribute the -2. -2 times x is a -2x. And then y'all finally the -2 times the 8 gives me a -16. And then all of this is still equal to 0. And y'all guess what? Before I distribute this x plus 1, I'm going to do one more thing to what I got inside the second parentheses. Do y'all see anything that I can do inside here?
Like terms.
Like terms, there you go. So it'll be easier to multiply this first set of parentheses by 3 things versus 4. So I'm going to bring down the x plus 1, and then I get what, an x squared. 8x's minus 2x's will give us a 6x minus our 16, all equal to 0. So see what would have happened if you'd have FOILed these first two. You had 3 things in the front and 2 in the back, which you could still FOIL, but it's a little trickier. So now I'm going to sort of FOIL this again, although there's going to be more than 4 things we do here, okay? But it's still going to follow that same principle. I'm going to take this x and multiply by all 3 of those first. Then I'll come get that 1 and multiply by all 3 of those. So everything in my first parentheses will be distributed. So y'all, if we multiply everybody by x, all we're doing is adding 1x to everything. So the x and the x squared will give me my x to the 3rd. That x times 6x will give me a 6x squared. And then that x times that -16 gives us a -16x. So we distributed the x. Now we come in and distribute the 1. So 1 times x squared is just x squared. 1 times 6x is a 6x. 1 times -16 is a -16. And then that's still all equal to 0. So y'all look, it looks like the last thing we got to do is combine a few like terms in here, and then we'll be done. So I'll bring down my x to the 3rd. So let's see, I can add the positive 6x squared to the positive 1x squared. So 6 and 1 will give us 7 of the x squareds. Then this -16x will add to the positive 6x. So let's see, -16 and 6 will give us a -10x. At the end, bring down that -16. Now, all MATLAB wants is this polynomial right here. You don't have to put in the equal 0 or anything. And on some of these, I think like the first one, they'll give you the x3, they'll give you the -10x and the -16. All they want is what number's in front of the x squared, which would be the 7 on this. But look at the answers, but mostly all they're interested in is our polynomial. And look at that, it's an x to the 3rd, which means it ended up being a degree 3. So y'all, let me see if y'all got questions on that. So this is the section I was talking about where we do a lot of FOILing, okay?
I do have a question. So on the first group of 3, when you said only for the last 2, I think I missed your reasoning for that.
On which ones now up
The
here?
first group, right
Oh,
there.
Yeah, because see down here, I had my two things in front followed by three.
Mm-hmm.
If I'd have foiled these first two up here, I'd have had three things in front followed by two.
Okay.
So that would have given me three things that I would have had to distribute, but it would have worked and you'll get the same exact answer. But I think they're easier to follow when you got fewer things up front than you do in the back.
Okay, gotcha. Thank you.
Mhm. Now, y'all, this one says write a polynomial whose zeros are 4, 7i, and negative 7i. Now, this one, I am really picky. I do keep the imaginary stuff to the back, sort of in the order they got it here. So I got my 3 zeros. So that means x equals 4, x will equal 7i, and x will equal a negative 7i. All right, y'all, same thing we did up here. We need a 0 on the right side. So we add the opposite to each equation. So the first one, I'll subtract 4, and I get x minus 4 equals 0. Subtract 7i, and I get x minus 7i equals 0, and then add 7i. And y'all, that one will give me x plus 7i equals 0. All right, y'all, so remember at this point now, I'm going to put everything in parentheses equal to 0 like we did up here. So I'll have my x minus 4, x minus 7i, x plus 7i, all equal to my 0. So y'all, this one, since I got these imaginary parts in here, I would definitely start out by foiling those imaginary numbers. Now, these are conjugate pairs. So I'm going to foil that on the side here for you. And then when I get that answer, I'll bring that down here and put it behind this x minus 4. All righty. So here's the nice thing about conjugate pairs when you got imaginary numbers. If you foil conjugate pairs of imaginary numbers, the imaginary I goes away. So you'll just end up with your x's and a number. So all the imaginary stuff will go away. All right, let me let one in real quick. So let's foil this and I'll show you how that works. So we got an x times an x, that'll be an x squared there. X times 7i gives me a positive 7i x. Then we distribute that negative 7i times x. I get a negative 7i x. And then y'all watch this. Negative 7i times a positive 7i is a negative 49i squared. So remember that I times I, just like a variable, becomes an I squared. So y'all notice what happens here in the middle. You got a 7ix and a negative 7ix.
They cancel.
So they definitely cancel. And here's another thing about these i's. Anytime you get an I squared, that I squared equals a negative 1. So anytime you get an I squared in these equations, replace it with a negative 1. And all that negative 1 is going to do is change the sign of that number right in front of it. So if this was a negative 49i squared, and I replace that I squared with that negative 1, well, y'all look at that. That negative times negative will make that a positive 49. So this ends up being an x squared plus 49. And y'all, I'll tell you this, anytime you foil imaginary numbers like this, it always ends up x squared plus whatever these numbers are times each other. So if this was a 8, x minus 8i, x plus 8i, it would end up at x squared plus 8 times 8 is what, 64. So y'all, let's replace that over here now. So I got an x squared plus 49, all equal to my 0. So I'll bring that over to show you where I'm sticking it in. So y'all, what's nice about this is probably easier than these up here, because up here you had 2 things times 3, but the conjugate pairs took care of that middle stuff. So you just got 2 things times 2. So let's see what we get. How about that? An x times x squared gives us the x to the third. And y'all, I'll tell you this. The highest exponent you get, it's got to be equal to the number of zeros you started with. I started with 3 zeros. The highest exponent has to be a 3. Up here, we started with 3 zeros. So our highest exponent was a 3. Okay. All right, y'all, now what we got? X times 49 will give us a positive 49x. Now I'm going to distribute my -4. -4 times x squared is a -4x squared. And then y'all, this is going to be a big number here. Let's see. -4 times 49.
-196.
-196. And all that equal to my 0. So y'all, there's probably only one thing I would do to that, because notice we don't have any like terms. But there is one thing I'd probably do to that, and it's put them in order. From my biggest exponent to my next, and then my number. So I'm just going to rearrange it. So that I get my x to the third minus my 4x squared. So keep the signs the same when you rearrange them. Plus the 49x minus the 196. Now, at that point, all MathLab wants again is that polynomial. So y'all, basically the same as this problem, except on this one, you want to start with the imaginary first and FOIL them, because if you started with the 4 and the 7i, you'd have had a lot more stuff than you want to FOIL, okay? All right, so what's questions on that one?
Okay, so I have another one. This last one, when you rearranged it, what was that for again? Because we didn't do it to the first one.
So I'm putting in what we call descending order of my exponents.
Oh, okay, okay, yeah.
So my x to the third, x to the second, x, and then my number.
Okay.
All right, y'all, let's move on to some radicals. This is another thing that's a little tricky. So let me move my camera back up. So this one again says find a polynomial of lowest degree with zeros of a square root of 5, a negative square root of 5, and a 2. Okay, so square root of 5, negative square root of 5, and a 2. All right, 3 zeros means 3 equations. So I got x equals square root of 5, x equals a negative square root of 5, and then x equals, what was my last one? A 2. Because if you remember when you did the quadratic formula, you would get answers with these radicals on them, okay? So now we want to get a 0 on the right side. So subtract and add as we need to get them zeros. So subtract the square root of 5 on this one. So I get x minus square root of 5 equals 0. I'll add my square root of 5 to the second one. And I get x plus a square root of 5 equals 0. And then last one, we will subtract 2. So we got an x minus 2 equal to our 0. All right, we got them all equal to 0. So now we're going to set them as factors equal to 0 and put them in parentheses. And then what, x minus 2, all of them equal to 0. So y'all, this time I probably wouldn't do the last 2. I would probably do the first 2 because these are radicals. And guess what? They are conjugate pairs. So we're going to start with the first 2 and FOIL them. Because just like I did with the imaginary stuff, if you FOIL conjugate pairs of radicals, it will get rid of the radicals and we'll just end up with an x squared and a number. So I'm going to come over here on the side and we're going to FOIL that. And y'all, the middles will always cancel anytime you have conjugate pairs, no matter what they are. Okay, they can be radicals, imaginaries, or regular numbers. If they're conjugate pairs, they're going to cancel those middles. So y'all, let's do this. X times x is an x squared. X times square root of 5 is a square root of 5x. Now notice the x ain't under the radical. The x can't multiply by the 5. Stuff on the outside cannot multiply by what's under a radical. So you just got to put it to the outside of it, okay? Right here, negative square root of 5 times x is a negative square root of 5 times x. And then finally, y'all look at this. A negative square root of 5 times a positive square root of 5 is a negative square root. Now, since the 5 is underneath and this 5 is underneath, I can actually multiply them 5s together, and that gives me a square root of 25. So remember, when you multiply radicals, insides multiply by insides, and if there's anything on the outside, it multiplies by anything on the outside, okay? So let me ask y'all this. What happens here?
I think the
They
negative.
cancel.
Yeah, they cancel. The negative.
Those are going to cancel. So we got our x squared minus, and guess what? Square root of 25. It's 5, right? So in the long run, a square root of 5 times the square root of 5 equals 5. A square root of 7 times the square root of 7 would equal 7. So a radical times itself, you end up with whatever number was under that radical, okay? Now, when you FOIL radicals, they'll end up as an x squared minus some number. Remember, the imaginary stuff was x squared plus the number, okay? So we now can replace this x minus square root of 5, x plus square root of 5 with an x squared minus 5. Bring down to x minus 2, and all this is equal to 0 still. So this I just brought over here and put in there. So y'all notice this ain't bad now. I got 2 things times 2. So once again, I will FOIL this. So y'all probably get a little sick of FOILing after this homework. All right, y'all, let's see what we got. X squared times x is an x to the 3rd. X squared times negative 2 is a negative 2x squared. Then I'm going to do the inside. Negative 5 times x is a negative 5x. Negative 5 times negative 2 is a positive 10 equal to my 0. And guess what? All Math Lab wants is our polynomial. So remember, 3 zeros, I ended up with an x to the 3rd. All right, y'all, let me see what my chat's saying. Okay, just someone saying they're back. Okay, good job. All right, y'all. So on the problem I did with imaginary and the problem with the radicals, remember, the first thing you're going to FOIL is those conjugate pairs of the radicals, okay? All right, y'all. So one more FOILing and then we'll sort of play with other stuff. This one says find a polynomial degree 3. With zeros of -1/2, 0, and 3. So 3 real numbers on this one. And y'all, I'll tell you the truth on this one. When I write my 3 equations, I'm going to start with 0 first. So I'm going to put x equals 0 first. Then I'll put x equals -1/2. Put the x equals 3. So anytime you got a 0 of 0, write it first. Because when we get to it, we don't actually have to FOIL it. We can just distribute it, okay? Now notice, it's already got a 0 on the right side. So all we got to do is fix the second 2. So the first one, we're going to add 1/2 to both sides. And I get x plus 1/2 equals 0. And y'all, guess what? We don't want a fraction here. So the next step, what I would do is multiply all 3 of these by 2. So I'll have 2 times x plus 2 times my 1/2 equals 2 times my 0. So notice what it does. It gives me a 2x. Here the 2's cancel. All that's left is the 1. And then over here, we're not changing anything. 2 times 0 is still 2. So here's the thing. If you got a denominator, when you write the factor, the denominator goes in front of the x, and then the number on top will be behind it. All right, y'all, one more. Subtract 3 from both sides, and I get x minus 3 equals my 0. So I got my 3 factors. Now y'all look at this. This is just the x. So that x, I don't even have to put it in parentheses because there's not another number with it. I can just throw the x in front of all my parentheses and then put in my 2x plus 1. Put in my x minus 3 and set them all equal to 0. Okay, so y'all, if this was, say, a -1/5, I'd end up with a 5x plus 1, okay? -1/7 would have been a 7x plus 1, and so on. So this one you can do many ways. I find that if I do the last 2 together, if I FOIL them, then my last step is pretty easy with that x. So I'm going to come on the side and FOIL 2x plus 1 times my x minus 3. All right, y'all. So once I get this answer, I'll bring it down and replace those 2 factors, okay? So we're going to get what? A 2x squared. 2x times -3 gives me a -6x. And then I got 1 times x is x. 1 times -3 is -3. Adding or like terms, we get a 2x squared. Let's see what I got. -6 and 1 give us a -5x. And then bring down that -3. So y'all watch this. We got our x. And then let's bring this down and put in our 2x squared minus 5x minus 3. All right, y'all. So look at that. Our last step now is to take this x and distribute it through these parentheses. All we're doing is adding the x to everybody. So x times 2x squared is a 2x to the third. X times negative 5x is a negative 5x squared. And then the x times negative 3 is a negative 3x, all equal to my 0. And y'all guess what? That is our final step, and all this stuff is in descending order. So MathLab wants that right there. Now, I did notice sometimes on some of these answers, you got to watch what they got in the blanks. Because if they got X3s in the front of all of them, what they're doing at that point, they want this to be a 1 in front, so they're dividing everybody by 2. So watch this. 2x third divided by 2 minus 5x squared divided by 2 minus 3x divided by 2 equals 0 divided by 2. So y'all, what that's going to do, these 2's cancel, making that an x to the third. So you got to sort of see what they got in those answers to tell me to go further from this step, okay? So I was looking at the answers, and all these had fractions. So they wanted us to turn this back into fractions like we had up here with that 0. So now negative 5 halves will stay negative 5 halves, x squared. Can't do nothing with the negative 3 halves, so that'll stay negative 3 halves x, and technically all equal to my 0. So MathLab may want it in that version. So some of y'all, if they give you a fraction here, they're going to want you to probably divide that fraction out so that the first number on the first term is a 1, okay? All right, so let me see questions on that one. So I ain't gonna lie, that's probably the trickiest of the ones we've done because of that fraction, okay? And you know that MathLab is sort of picky at times. All righty, so let me move on then. I'm gonna turn my paper over, it's starting to rub up. All right, y'all, so the next thing they have us doing, they want you to know a few properties. So these are what we call theorems about zeros. And there's only 2 I'm worried about. The first thing, imaginary zeros. Imaginary zeros always come in conjugate pairs. %, they come in conjugate pairs. So what that means, if 5i is a 0, then negative 5i is also a 0. That's why they gave us a positive one and a negative one on that second problem we did, okay? If something like 3 plus 2i is a 0, then 3 minus 2i is also a 0. So notice when you got numbers in front, that number don't change. It's only the imaginary part that changes. And that's why we was foiling that 3 plus 2i stuff, 3 minus 2i stuff. All righty. So imaginary zeros 100% will come in conjugate pairs. That's the first one. The second one, the radical zeros our radical zeros always come in conjugate pairs. Which means in the long run, imaginary zeros and radical zeros come in conjugate pairs, right? So what that means, if square root of 5 is a 0, then a negative square root of 5 is also a 0. And let's say it had a number in front. If 2 minus the square root of 3 is a 0, then 2 plus the square root of 3 is also a 0. Okay, so which means if I got an imaginary 0 or a radical 0, I got to assume automatically that its conjugate is also a 0. So y'all with me on that? Conjugate pairs. So watch this. Suppose a polynomial degree 4 has zeros of -4, square root of 3, and 6/5. Find the other 0. So can any of y'all guess what my other 0 would be given a -4, square root of 3, and a 6/5?
Negative square root of 3.
Negative square root of 3. There you go. Because those always come in conjugate pairs. All right, let me try another one on you. Well, I'll do a couple more. Same thing, degree 4 polynomial. Has zeros of, how about I and 4 minus square root of 7? Find the other zeros. Now, one thing you got to realize is this 4 minus square root of 7 is like one number, okay? So they're giving me 2 zeros. So y'all, what is my other 2 zeros? Because remember, I need 4 of them because they gave me a degree 4. So if I is a 0, what's its conjugate?
-I.
If 4 minus square root of 7 is a 0, what's its conjugate?
4
Would it
plus
be
square root of 7.
Oh, what was that? I heard the last part was right, but I couldn't hear what y'all said.
4 plus square root of 7.
Yeah, 4 plus square root of 7. There you go. So remember, the sign only changes on the radical stuff or the I stuff and not that number in front. Y'all remember, these are kind of answers y'all got when y'all was doing that quadratic formula. Remember the plus or minus on the radicals? That's why they're both in conjugate pairs. All right, so one more of those, and then I'll move on. So y'all, same thing. Suppose a polynomial degree 4 has zeros of, my hands sort of got lazy on this writing after that week off for spring break. Let's see, 3 plus 3i and 5 plus square root of 3. So you know the question, find the other zeros. So what y'all think on that one?
Would it be 3 minus 3i?
I like that one.
5 minus the square root of 3.
5 minus square root of 3. Like that one. Good job. So I'll tell you why they wanted us to learn this real quick. Because they're going to make us do some more foiling in here. So let me let y'all catch up on the writing. And then we'll find more of those polynomials. All righty, y'all. So here we go. So watch this. Find the polynomial of lowest degree that has some of its zeros of negative 3i and 4. So this is doing like we did on problem 1, 2, and 3. They're giving me zeros, and then I'm going to set them up as equations and then start foiling, okay? So do I have all my zeros?
No.
No, so what's the other one got to be?
Plus 3i.
So the other zero is positive 3i. Good job. So that means, so see this one though, they want us to do more. They want us to actually find that polynomial. So this is where we're going to set 3 equations up. So I'll put my x equals 4 first. That way I can get these i's together. X equals what? Negative 3i. And then over here, x equals a positive 3i. All right, subtract and add to get the 0 on the right side. So you're going to subtract 4. X minus 4 equals 0. Add 3i on the second one. X plus 3i equals 0. And then finally subtract the 3i and get x minus 3i equals 0. All right, y'all, continuing on. We're going to put them all in parentheses. So x minus 4, x plus 3i, x minus 3i, all equal to my 0. Now, that's why up here they said lowest degree. They didn't want to give it away that it had 3 zeros. They wanted y'all to realize that 3i had to be a 0 because of the negative 3i. So y'all, let's I'm going to start with imaginary stuff again. So on my side over here, I'm going to do the x plus 3i and the x minus 3i. Now, y'all, I'm going to show you how to shortcut this. Because if you remember, every time we foiled conjugate pairs, they cancel the middles out. So I'm going to show y'all how to do what I call a shortcut foil.
Not give Bear any.
So the shortcut foil, you multiply the 2 x's together. So remember, x times x is an x squared. And then you multiply the last 2 together. So 3i times negative 3i is a negative 9i squared. Y'all, we don't have to foil the inners and outers because those always canceled 100%. So my question to y'all, this x squared minus 9i squared is not my final answer. What would be my final answer of this?
X squared plus 9.
X squared plus 9. Because y'all remember, I squared equaled that negative 1. And its only purpose in life is to change the sign of that number in front of it. All right, so then I'm going to bring down this x minus 4. I had what, an x squared plus 9. All that stuff equal to my 0. All right, y'all, so guess what? All we're going to do now is FOIL this last two things times these two and see what we get. All right, so let's go. X times x squared will be an x to the third. X times 9 would be a 9x. The negative 4 times x squared is a negative 4x squared. And then the negative 4 times 9 is a negative 36. All right, y'all, remember the last thing I would do to that. What do y'all think y'all would do?
Put it in descending order.
Put them in descending order. Good job, because I don't have any like terms, but I really need to switch these two in the middle. So let's go. We got an x to the third minus our 4x squared plus our 9x minus the 36, all equal to 0. And y'all remember, all Math Lab wants is our polynomial. All right, y'all. So that's mainly all the factoring, the foiling we got to do. The rest of this is going back and finding zeros. So the last time we found zeros, we were doing them by quadratic formula. But remember, in order to use a quadratic formula, I got to have an x squared type polynomial, right? It's got to be a degree 2 with an x squared. So what we're going to do to find zeros, we're going to use synthetic division. And we'll divide out the zeros until we get it down to the 3 numbers where we can use our quadratic formula. Now, some of these are pretty easy, so I won't use the quad. I'm going to factor them by taking square roots later. But let me show you what we got. It says the polynomial has the given 0. Then it says find the other zeros. So y'all, it'll look like this. They're giving me f of x equals, let's see, x to the third plus 4x squared minus 2x minus 8. And then the semicolon is giving me a 0 of negative 4. So what we got to do, remember, each time we do synthetic division, you get a quotient and a remainder. That quotient is what you use to find the next zeros out of. So we just got to turn this x3 into an x squared. So let's take out the first 0, which is a negative 4. So negative 4 will be my C. Now remember, here's my polynomial. So since we're doing synthetic division, we want to write down all the coefficients. And remember, if there were any missing exponents, I would have to use a 0. But y'all look, this one's got an x3, x squared, the x, and a number. So nothing's missing on it. So we'll just write down our numbers. We got a 1, 4, negative 2, and a negative 8. And then
I got a question.
Yeah, I hear you.
On that negative 4, is that supposed to be a positive 4? Down in the box to the left?
No, when they give you zeros like this, or if you were finding function values, you leave the sign the same.
Okay.
If they'd have gave me something like this, x plus 4 as my factor, when I give them to you in factor form, that's when you would have turned that 4 into a negative 4. Okay.
Okay.
So only when you got the factors, you got to worry about changing the signs. Now, y'all, let me ask y'all this. Since they're telling me that negative 4 is a 0, what should that remainder be when we're done?
0.
It better be 0. Good job. Because remember, that's how we was the last time we had class, when y'all were checking to see if they were zeros or not, they had to have that 0 remainder. All right, y'all. So remember, the first number we bring straight down into the box. And then we're going to start multiplying and adding until we're done, okay? So 1 times -4 is -4. 4 and -4 add up to give me a 0. 0 times -4 is 0. -2 plus 0 is -2. And y'all look at that. -2 times -4 is a +8. And that -8 and 8 give me a nice big 0. So remember, what this means, these are the coefficients of the polynomial that we now have. And remember, it starts 1 degree less than the original polynomial. That means this is a 1x squared plus 0 x's, so I don't have to write that, minus 2. So remember, I got an x squared at this point, so to find my last 2 zeros, I'm going to set that equal to 0 and solve it. So we can solve it once we get it down to an x squared by either taking square roots, trying to factor it, which this one don't, or using the quadratic formula. If you use the quadratic formula, A would be 1, B would be 0, C would be -2. But y'all, if you're doing the quad formula by hand, it's easier to solve these things by taking the square roots when you got an x squared and just a number. So to solve it by square roots, we're going to add 2 to both sides. And I get x squared equals a +2. Now I'm going to take square roots of both sides. So the square root of x squared is an x. So y'all, we can't do nothing with that square root of 2, but remember, I need 2 answers out of that. So the square root of 2 will give me what? A plus
Plus or minus.
or minus, there you go, square root of 2. So since this had a degree 3, they gave me 1 0 of -4. That means the other 2 zeros, and it'll probably say something like other zeros are, and then you'll just put in your square root of 2, negative square root of 2. And I actually think MathLab will let you put the plus or minus square root of 2 on that one. Okay, y'all, so you got to get it down to 3 numbers, and then you can solve it by any way possible to get them other zeros. But y'all look, this one we started out with what, an x to the 3rd. So I'll let y'all catch up a second, because we're about to start out with a x to the 4th. And if it's an x to the 4th I start with, that means I got to do synthetic division twice. The first time turns it into an x to the 3rd. The second time will turn it into an x squared, which I can start trying to solve, okay? All right, y'all, so let me see what we got next. All right, let me move that back up for us. All righty, y'all. For the following polynomial, uh, 1 0 is given. So the same as we'll go. So 1 0 is given, and then it says find the remaining zeros. All right, so let me see. My polynomial is going to be p of x equals x to the 4th plus 40x squared minus 441. And then it says 7i is a 0. All right, so I'll probably need a calculator. That looks like it's got big numbers on it. All righty. So the first number I'm checking is 7i. So that'll be my first C over here, 7i, my first 0. Now y'all be careful on this one. I got an x4. I don't have an x3 term. I got an x squared term. I don't have an x term. And then I got my negative 441. So when I don't have the x3 term and the x term, I got to put zeros. So I got a 1 for the x4, 0x to the third, 40x squareds, 0 x's, and then my negative 441. And y'all, once again, since 7i is a 0, when we're done, we better have a 0 here, okay? All right, y'all, guess what? Bring 1 times 7i is a 7i. Zero plus 7i is 7i. All right, y'all. 7i times 7i. That equals 49i squared. So what does that turn into?
Negative 49.
Negative 49. And y'all, I'll show you something else. If you want to multiply them little, I'll show you on this calculator here. You see what I have, 7i? You see down here by the decimal, above it is a blue I. If you hit the second button and the decimal, it puts up the I. So then I can multiply by the other 7i. So second decimal to get the I. And y'all look at that. It's going to give me, it says negative 49 plus 0i. That's because my mode is in that. Let me change my mode back here to real. Oh, I guess it's already in real. Maybe it's just going, oh, I guess because I got the imaginary stuff. But remember, 0 times I is the big 0. So this basically equals a negative 49, okay? Oh, I guess because I'm in the CE version. If I was on the regular calculator, it would probably just give me a negative 49 there. But I think it's just because I'm in the CE version. Let me switch my calculator and see. I'm going to switch it to a regular 84 plus. So let me try it on here. 7 second decimal times 7 second decimal. So the older ones give you the negative 49. Just remember, if you got the new CE and you're using it and it gives you a 0i, that basically is a big 0. So just use the negative 49. All right, y'all. 40 and negative 49 give me a negative 9. Negative 9 times 7i is a negative 63i. 0 plus negative 63i is a negative 63i. And I know this, I know the I squared, so y'all see what negative 63 times 7 gives us. I'm hoping that gives us like a negative 441. So let me punch that up real quick. What I say, negative 63 times 7i. Yeah, I'm getting a negative 441i squared. But remember, I squared equals negative 1, so that's going to turn that negative 41 into a positive 441, which gives me a remainder of 0. All right, so now we turn the x4 into an x3, but remember, we got to turn it into an x2 before we can start solving it. So we got to get these 4 numbers turned into 3. Okay, you got to have 3 numbers before we can start with the quad. So what's nice, these 4 numbers here are going to be the coefficients of the next synthetic division. So you bring them straight out of the box as your new coefficients. Y'all, I need to know what number I can try next. And all they gave me was a 7i. So what y'all think I need to try next?
Is it a negative 9i?
Oh, you're really, really, really
A
close.
negative 7i.
Negative 7i. There you go. Because remember, these come in conjugate pairs. So they gave me the 7i. So I automatically got to assume that that negative 7i is also a 0. Well, good job. So that's what I like, y'all paying attention to that conjugate stuff. Now, when we get done with this one, we'll have 3 numbers. And them 3 numbers, I can start doing my quad, my square roots, or factoring, or whatever we got to do. And y'all remember, if negative 7i is a 0, I better get a 0 remainder over here, okay? So y'all bring down the 1. 1 times negative 7i is a negative 7i. 7i, negative 7i, give me a 0. 0 times negative 7i is 0. Negative 9 plus 0 is negative 9. And then negative 9 times negative 7i is a positive 63i. So remember, you only get the I squareds when you got an I times an I, but this one only had a number times that, okay? And guess what? That gives me my remainder, like we said, of 0. So for my other zeros, the first one I know is the negative 7i. So we're going to use these 3 numbers to get the last 2 zeros. So remember, I started with an x4. This was an x3. This now becomes an x squared. So I got 1x squared plus 0 x's minus 9. I'm going to set them equal to 0 and solve for my last 2, okay? So y'all, since I got an x squared in the number, I'm going to add 9, and then I'm going to do my square roots. So we'll do the square root of x squared will equal to square root of 9. So y'all, that means x equals what?
Is that 3?
Or
Negative 3.
negative 3. So remember, all the square roots, you always got to get me 2 answers out of those. So y'all, good job. So that means my other zeros were 3 and negative 3. So they gave me 7i. We found the other 3, which were negative 7i, 3, negative 3. All right, so that's all I'm going to kill you on the synthetic division. So the last topic on the college algebra part of this deals with finding all possible rational zeros. So the rational zeros are the zeros that are not imaginary or radical. So up here, remember, they gave me numbers to check. But what this section does is it gives you all the possible zeros that you can check in synthetic division. And if you get 0 remainders, then you know that number would be a 0. But it would have to be one of these possible rational zeros. So to find all possible rational zeros, we take all the factors of the last number and divide by all factors of the first number. So y'all, depending on how many factors these numbers have, will sort of determine whether I got a lot of numbers I'm about to write or just a few, okay? So the more factors, the more possible zeros, okay? So remember, I'm going to take all the factors of the last number and divide by all factors of the first number, and then I'll use the plus or minus, because remember, they could be negative or they could be positive. So y'all, I'm going to start that on the other side here. Now, these aren't too bad. They're more tedious than anything. So let me see here. I'm going to find all possible rational zeros of, let's see, we got a P of X equals 33x to the third minus 38x squared plus a 42x minus 10. So now all of these won't be zeros, but some of these will be zeros of this polynomial, okay? It'll be possible zeros. So if I was finding zeros, some of these answers we get would be some of their actual zeros. So remember, my last number is 10. And y'all, at this point, we don't even care about the signs. We just want the numbers. So the last number is 10. The first number is 33. So the first thing I want is factors of my last number. So factors of 10 would be what? 1, 2, 5, and 10. So 1 times 10 and 2 times 5. Only way to multiply to get me a 10. Now I'll do that with the first number. So my first number was 33. So I think there's only a couple ways to get a 33. It'll be 1 times 33 and then 3 times 11. So 3 and 11, 1 and 33. Okay. Now, I'm going to take each of these numbers from the last number and divide them by all 4 of these numbers. And each time I do that, I'm going to keep a plus or minus in the front of it. Because remember, these factors could be positive or negative. So let's start with the 1. I'm going to do 1 divided by 1. Plus or minus 1 divided by 3. Plus or minus 1 divided by 11. And then plus or minus 1 divided by 33. Now, y'all look at them 4 fractions. Can you simplify any of them 4 fractions?
Wouldn't the top one be just plus or minus 1?
Plus or minus 1. There you go. And then the rest of them are bigger on the bottom, so can't simplify them. So that takes care of the 1 being divided. So now we do that with the 2. We'll do plus or minus 2 divided by the 1. Plus or minus 2 divided by 3. Plus or minus 2 divided by 11. And then plus or minus 2 divided by 33. All right, any of them fractions be simplified?
The 2 divided by 1 would just simplify into 2.
So plus or minus 2. So basically, anything I'm going to divide by 1, we're going to simplify down, it looks like. All right, y'all, that takes care of the 2. Next, we got our 5. So that'll be a plus or minus 5 divided by the 1. So we know that's going to simplify into just a 5. The 5 divided by 3. The 5 divided by 11. And then the 5 divided by 33. All right, y'all, that takes care of the 5 we just did. So what's left is our 10. So we got a plus or minus 10 divided by 1, which will turn into a plus or minus 10. Plus or minus 10 divided by 3. Plus or minus 10 divided by 11. And then plus or minus 10 divided by our 33. Now I'm telling you what, if I had to do these, I'd probably start with these whole numbers first. Do 1, -1, 2, -2, 5, -5, 10, -10, praying that I got a 0 remainder, because if I didn't, then I would start having to do these numbers and checking all these numbers with synthetic division until I actually got a remainder of 0. So y'all look, that could be 2, 4, 6, 8 times 4. That could be 32 times you did synthetic division before you found a 0 actually. So I'll tell you, I don't use this method a lot. Usually when I'm looking for zeros, I graph it, because remember, zeros are where those x-intercepts are, which is probably a little easier than doing all this synthetic division. So y'all, you'll have 2 doing this. They're not too bad. So now what I wanted to do, I want to do a little bit of support stuff with you. So let me write these back here. Because the support had a few questions that were sort of tricky on it. Because I know how y'all like foiling. So let me fix my paper and we'll do a few of these support problems. So these will be from support 8.4. So y'all here, I got one, a R plus a G times R squared minus RG plus a G squared. So the support was to get you ready for all that foiling we did a while ago. So remember, I got 2 things times 3, sort of like my first problem did. So we'll take the R, distribute it, then we'll take the G, distribute it. Now remember, if it ain't got an exponent by it, it is definitely a 1. Okay? So this R would be a 1, G would be a 1, and then this R and G both here would both have exponents of 1. And we're just going to add exponents. A R times a R squared, 1 plus 2 gives me a R3. The R times the negative RG will be a negative R squared G. So basically, we're just adding the R to everybody. The R times the G squared will be a positive RG squared. So when you multiply the R, the only things that can change are the R's, okay? Now let's do the same thing with the G. G times R squared is a positive G R squared. G times negative RG is a negative RG squared. So notice all I'm doing is adding G to everybody. The G times the G squared is a G to the third. So y'all, now is the time when I'll probably add like terms. Now notice here. Here you got an R squared G. Here you got a G R squared. They're like terms, they're just out of order. But if I was to put this in an order, I'd get a negative GR squared, positive GR squared. Guess what? Those are going to cancel. Now, the next like terms will be the RG squared and the negative RG squared. Well, 1 RG squared and a negative 1 RG squared, those ones are going to cancel for us. So look what's left. I got an R3 plus my G3. Final answer. So this was just to sort of get you ready for what was coming up in that 8-4 homework, okay? So let me do another tricky one. Y'all gonna love foiling after this, right? Y'all gonna have nightmares about foiling. Y'all look at this. T minus R times T plus R times T squared minus R squared. So I'll tell you the truth. If I was to do this one first, look at this. T minus R, T plus R. Y'all, those are conjugate pairs. So I would probably start out with those ones first. So on my side, I'm going to do a T minus R and a T plus R. Remember, since these are conjugate pairs, I'm going to shortcut FOIL. So shortcut FOIL since conjugate pairs. Now I can't do this if they wasn't conjugates, but since these are conjugates, we can do that. Which means do the first two. T times T is a T squared. And then do the last two. Negative R times R is a negative R squared. So these first two turned into a T squared minus R squared. And then I'm going to bring down the other one, which is a T squared minus R squared. So that one I basically put right there. Now, y'all don't be fooled. These are not conjugate pairs because both of these are negative. So since one's not negative and one positive, I don't get to shortcut this one. We're actually going to FOIL this one out. Long method. Okay, so let's see what we get. How about this? A T squared times a T squared.
2T4.
Oh, you're so close, but remember, that's a 1 times a
It's
1.
squared, right?
Huh?
2T squared, right?
Well, I like the T part will go, but not the 2.
Would it be T to the
T
fourth?
to the 4.
T to the 4. Yeah,
Um,
remember, when the only way you can change the numbers in front, if they're just ones, is we're just multiplying the 1 times 1 to get to 1, and then a T squared and T squared give us a T4. All right, now try this. T squared times a negative R squared is a negative T squared R squared. All right, y'all look at this. Starting in the middle, negative R squared times T squared is a negative R squared T squared. And then y'all, a negative R squared times a negative R squared is a positive R to the 4th. Y'all, I'm going to tell y'all these right here. I got an R squared and a T squared. These are like terms. They're just out of order. Okay, I can rearrange this one and make it a negative T squared R squared. Remember, these are like terms, but they're not opposite in sign. So that means they're not going to cancel. So I'm going to bring down my T4. Whoops, my T4, I said. -1 and -1 give me a -2 T squared R squared. And then finally, I'll bring down my R to the 4th. Now, MathLab should take that. I don't think they're picky about putting them in alphabetical order, like making this a R squared T squared. I think it'll take it any way we put it in there, okay? So the support starts out a little heavy on this just to get you good at foiling for our college algebra part. Now I'm going to sort of play with some imaginary stuff. So y'all, this next example, I got a -4i times -4 plus 8i. So we're going to distribute the -4. So y'all, -4i times -4, that's going to be a positive 16i. And then let's see what we get here. Negative 4i times 8i is a negative 32i squared. So you don't have like terms, but y'all, can I go further with this?
Yeah, the I squared is a -1.
I squared is a -1. There you go. So bring down that 16i. And that negative 32y squared is going to turn into what?
32.
There you go, positive 32. Now, the only thing we would do in math lab, they want the real part first and then the imaginary part. So we need to put it into A plus BI form, which means put the 32 first and then bring down your positive 16i. And y'all, this part of support was to get you used to that I squared being a -1, okay? And so always doing it turned to negative 32 positive. That's its only purpose in life, okay? Is to change the sign of them numbers. All right, 7 plus 4i, 8 minus 3i. So these are not conjugates, so we're going to have to pull this whole thing out. So y'all, let's see what we got. 7 times 8. Oh, what's that? That's like oh, that should be what, 56? 7 times negative 3i gives me a negative 21i. 4 times 3i gives me a positive 32i. And y'all, finally, that 4i times negative 3i is a negative 12i squared. Whoops, that's a minus here. Let me put it up there where it goes. Okay. So y'all, the first thing, we got like terms in the middle. And then that I squared is going to equal a -1. So let's bring down our 56. Woo, what do we got? A negative 21 and a 32i. So 32 minus 21 is what? A positive 11i. So the negative 12i squared now becomes a positive 12. So y'all, let me ask you this. Can you go further on this one?
Can't you add the 12 and the 56?
I can add the 12 and 56. Because once that I squared turns that into a opposite sign number, it will then add to the first one. Good job. So I'm going to add them first, and then I'll put the I last, and we'll be done. So let's see, 56 and 12, that's what, 68 plus my 11i, and we're done. Now, I will say this, when you're messing with imaginary numbers like this, the most you can end up with is 2 terms, a real part and an imaginary part, okay? All right, y'all, then they started doing some of these, which we done seen these. 9 plus 3i times 9 minus 3i. Y'all, guess what? These are conjugate pairs. Since they're conjugate pairs, I can shortcut these. So I'm going to shortcut my FOIL. So remember, when I shortcut FOIL, I'm going to do the last 2. So what's that? 9 times 9 is 81. And then we're going to do the last 2. 3i times negative 3i is a negative 9i squared. So once again, I squared is -1. So y'all look at this. That's going to give me what? 81. What's next?
+9.
So let me ask you that. Can you go further?
90.
Yeah, because now we got like terms again. And 81 and 9 gives me 90. Y'all check this out. When you FOIL conjugate pairs of imaginary numbers, you'll end up with a single real number. Because remember, all the I stuff goes away when you got conjugate pairs. All right, let me see. Let's do one more of those. So they give you two of these with conjugates. This one has 5 plus 2y, 5 minus 2y. Once again, I got conjugate pairs, so I'm going to shortcut FOIL. And these were just to get you ready for all that FOILing we did with imaginary stuff on the regular 8.4. So y'all, that means 5 times 5 is what, 25? 2y times negative 2y is a negative 4i squared. All right, y'all, so lead me through the rest of this.
Wouldn't it be a negative like over there by the I squared? So that'll turn it into a positive 4.
Okay, so I got 25 plus 4, so you got one more step.
You add those together, that gives you 29.
29, there you go. Once again, conjugate pairs gave me a single real number. All right, and y'all, I think there's one more on there, but it's just solving an equation. You'll probably have to use the quad formula for. And it was just to get you ready for when we got to the quad formula on those problems we were doing. But that's mainly, I wanted to show y'all all this fun stuff in that support, okay? So I think it had like 7 problems, these 6, and then one where you just solve one, okay? So y'all gonna be doing a lot of FOILing tonight, right? All right, y'all, any questions? So what we'll do, your 8.4 stuff tonight. Next class, we'll do 5.1 and 8.5. 5.1 is really short, and it's pretty much the same stuff as 8.5. It's doing domain of the fractions again. But this time they want us to use interval notation and stuff like that. So we'll hit that stuff on Wednesday. And that'll be, like I said, 5.1 and 8.5. Next Monday, we'll come in, knock out 8.6. And then we're going to start getting ready for test 3, okay? So we just got a couple more sections and we'll have all the test 3 material knocked out. And then it's easy sailing going toward that final, okay? Oh yeah, I was wanting to remind y'all, April 4th, which is, I think that's next Tuesday. It might be Monday, but I'm not sure. But April 4th is when current students can register for their summer classes or next fall, okay? And y'all get on there quick because some of them classes filled up really quick. So especially if you're nursing and stuff and you got to take all them sciences, get on there and get them.
Can you repeat that for me again? I'm sorry, I missed that April 4th.
So April 4th is when current students like y'all can sign up for your fall classes, or if you're going to do summer 1, summer 2, and all that.
Okay, thank you.
Okay. And I think you just go into the portal, go to the student section, and there'll be all them squares they got there. One of them will say add and drop classes. You can go there, pick what semester you're going, and then try to find your classes, okay?
Okay, thanks.
All righty. All right, y'all, any questions on anything we did tonight or anything? All right, so I'm going to stop my share.
So I did have a question. You said the it was a conjugate term.
Say again now.
There is conjugate terms, what you stated it was?
Conjugate pairs.
Yeah. Oh, conjugate pairs. Okay.
Uh-huh.
All right.
Yeah, and you'll notice they're going to be identical except for the one being plus and one being subtraction, okay?
Okay.
Yeah, that's why that support had so much of the I stuff in it, was getting y'all ready for that. And then like problem 5 and 6 in support were actually doing the conjugate pairs. And they just want y'all to see on the conjugates with the imaginary stuff that the I pretty much went away and we got them single numbers on those, okay?
Okay.
All righty, y'all. So I'm gonna stop the recording.